Okay, so we have a triangle ABC with 3 lines of position, and I've already constructed the symmedian point. I also got the centroid, which is where the medians cross, the lines to the midpoints. And getting the midpoint, I drew the perpendicular bisector anyway, and they meet at this point, the circumcenter, the center of the circumscribing circle. So if I put my compass through that and through the vertices, then I can draw this circumcircle, which I'll need. So I got O, the circumcenter, and G, the centroid, the centre of gravity, for free in constructing the symmedian point. What I'm going to do now is construct the axes of the ellipse and an example of the least squares ellipse. So first of all, I'm going to draw the Euler line. So the Euler line goes through quite a few of the well-known triangle centres, but in particular it goes through O and G. What I'm looking for next is the orthocentric circle, and the centre of that is the same distance from G as O is, so I can just strike off that distance a radius of the circumcircle there, and that gives me a point which I'll call D. It's unfortunately clashed a little bit. So actually, if I wanted the orthocentric circle, I can now draw it centered on D, and it turns out that point is H, the orthocenter, but I don't actually need that one. My aim is to construct the point that's on the major axis of the least squares ellipse, the point we call x1344. So that's the incentre of similitude of the circumcircle and the orthocentric circle. And it's quite easy to make. What I do is draw a diameter of this smaller circle, the orthocentric circle. I could draw any diameter, but I'll need to be able to reproduce it down here. So just for the sake of being definite, I'll draw it through the intersection point of those two circles. Okay, so I can now use my parallel rolling ruler, or I could use traditional navigators' parallel rules. But what I want is to copy that diameter of the smaller circle to make a diameter of the larger circle there. Okay, so now to get the point I want, all I do is I join the points at either end of the diameters. So it turns out that the point that I want actually lies on the Euler line. So it's gone very slightly missed there actually. Let me just do that again. Okay, so that is the point x1344, and that point is on the major axis of the ellipse. So remember, there's the triangle, and the major axis of the ellipse is going to join that to the symmedian point. So that's the major axis. The minor axis is perpendicular to that. Just do it with the rolling ruler, but of course I could construct a perpendicular or whatever I like. I'll use a set square. So that's the minor axis. In fact, had I joined these points at the same ends of the diameters, it would have met at the point that's on the minor axis. But in this case, it might have been off the paper, so not quite so convenient. Okay, so that's the system of axes, and all the least squares ellipses for any sum of squared distances will have those axes. Our task now is to draw an example of one of those ellipses.